Unit 2, Lesson 8, Proving Lines Are Parallel. So there is relevant vocabulary, things we've covered already, angle relationships that you need to know, and properties and postulates and theorems that, again, you need to know. So we're going to recall Lesson 7 briefly, as we need that for Lesson 8, as they are closely related. So there are 3 parallel lines theorem used when given the lines are parallel. That was what Lesson 7 was on. And there are 3 opposites or reverse theorems based on those parallel line theorems that are used when proving the lines are parallel. And that is this lesson, Lesson 8. So again, we're going to focus on the converse of those theorems. So what does that mean? If we can logically demonstrate that any of the relationships exist, then we can conclude that the lines are parallel. So if we note that alternate interior angles are congruent, or that alternate exterior angles are congruent, or that corresponding angles are congruent, or if consecutive interior angles sum to 180 degrees, then we know that the lines have to be parallel. That's what the converse states. All right? Where going forward, the originals say that if the lines are parallel, then we know that this property holds. Right? But again, we don't know that the angles are necessarily have that relationship. We don't know that. So we cannot use the relationships above unless they are given, or unless we can logically demonstrate that they exist, meaning that we have proved in some way. Proved. So we cannot use the relationships above unless they are given to us in given information, or unless we prove through some other means that they exist. So let's see some examples. All right, so for example 1, I'm going to show you 2 ways of doing this proof. All right, one is really short, and the other is a little bit longer. So depending on what you remember, what you notice, that is the method that you'll use. So again, we're being given that angle 2 and angle 1 are congruent. We are given that information. We want to prove that the line M is parallel to line N. So I'm going to set up my 2 columns. So I've set up my 2 columns here, my statements and my reasons, and we know that the first line of every proof is what you're given. Angle 1 congruent to angle 2. How do we know that? They gave it to us. So if you notice, the angles that they gave us are alternate interior angles. They gave them to us. They told us that those are congruent. So secondly, I can state that angle 1 and angle 2 are alternate interior. How do I know that? That's what they're defined to be at. That's their location. Definition of alternate interior angles. And because they gave me that those alternate interiors are the same in the given information, I can't assume that they are the same, but they gave it to me, I can now conclude that M is parallel to N. And for your concluding reason, you have 2 choices. This is the converse of alternate interior angle theorem. But if you don't remember what that states, or what the name of that theorem is rather, then you have to state it. So if 2 lines are cut by a transversal, then the alternate and the alternate interior angles formed are congruent, then the lines are parallel. Again, simpler to just write converse of alternate interior angle theorem. But again, if you don't remember the name of that theorem, then you need to describe or explain the theorem specifically. So let me show you another way of doing this proof. Here's the second method that you could use. Angle 1 is congruent to angle 2, again, given. We can say that angle 2 and angle 3 are vertical angles. Definition of vertical angles. And so we know that angle 2 is congruent to angle 3. Vertical angles are congruent to one another. Alright, well now we can say that angle 1 and angle 3 are congruent through substitution or transitive. And notice that angle 1 and angle 3 are corresponding angles. So for my final statement, I can say that M is parallel to N. And again, I have two options. I can say converse corresponding angle theorem, or I can explain what that theorem states. So if two lines are cut by a transversal, such that, and the corresponding angles formed are congruent, then the lines are parallel. Okay, so those are your two options for how you can prove that a given pair of lines are parallel.